when the object is at infinity. That means the object is much very far away from the mirror. So we can consider an object at infinity. That means an object is very far away from the mirror. So this is the mirror, concave mirror, because we are considering concave mirror only. This is the principal axis. So this is the pole. Now the object is very far away. So when the object is very far away, then the rays of light from the object are always parallel to the principal axis. Suppose it's an object which is very far away. So the rays of light will be parallel to the principal axis. All the rays will be parallel to the principal axis, like sun. The sun is very far away from the object or from the mirror. It is as good as at infinity, and therefore the rays of light coming from the sun are parallel to the principal axis. So we know that the rays which are parallel to the principal axis after reflection pass from the principal focus. So this is the principal focus. So it will pass from the principal focus after reflection, pass through the principal focus like this. So this point at the principal focus will become the image of that object. Therefore, the image in this case is point size image, very small, highly diminished. The nature of the image is, the size of the image is highly diminished. And second is because the rays are actually passing, actually meeting at one point, that point becomes the image, and that image, what type of image it is? It is the real image. So it is a real image, and also where the rays actually meet, the image formed is inverted. So nature of the image is real and inverted. The size of the image is highly diminished, and nature of the image is real and inverted. And the third, the position of the image is at principal focus. Okay, so this is the case when the object is at infinity. Now, second case is consider when the object is beyond the center of curvature of the concave mirror. So, object beyond center of curvature of the mirror. Mirror in this case is concave. So that means object is at finite distance but beyond center of curvature. This is center of curvature. Object is still far away but not at infinity. So this is the pole, center of curvature, principal focus, and object is beyond the center of curvature. So it is somewhere here. Suppose A, B, the object at position O. And the rays from point A, now ray from point B will be along the principal axis. And now because the principal axis is normal at point P, that means the angle of incidence is 0. And therefore, it will be making a 0 angle with the normal at point P. and will be reflected back. So that this is the direction. Along the same direction, the ray is reflected back. That means B point is lying somewhere on the principal axis. So the image of point B is always on the principal axis. Now let us find out the image of point A, and we can consider two rays. When the ray from the point A is parallel to the principal axis, ray we consider is parallel to the principal axis. And we know whenever a ray is parallel to the principal axis, it always after reflection passes to the principal focus. So we have drawn ray which is reflected and passing to the principal focus. Now let us consider another ray which is passing from the center of curvature. So a line from E and it goes to the at any point on the surface of the mirror. We know this is the line, the ray passing through the center of curvature, and the line, a ray passing from the center of curvature is always along the normal to the surface of the mirror at that point. Be reflected back along the same direction. We have already considered this case. So this is reflecting back along the same direction. So one reflected ray is this. Let us this K L is one reflected ray, and this another reflected ray is, suppose this point is M. So M is another reflected ray. So these two rays are meeting at this point. So this point will become the image of point A, because after reflection, rays from the point A are actually meeting at this point. So this point represents image of point A. So draw perpendicular A on principal axis, and we know the reflection, the image of point B lies somewhere on the principal. So this will be the image of line of point B. So therefore, A dash B dash, what is the position of the image? The position of the image is now between F and C. So when the object is beyond C, beyond the center of curvature, the position of the image is between F and C. So between center of curvature and principal focus. The image is formed between the center of curvature and the principal focus. So that is the position. Nature of the image, because the rays are actually meeting at this point, dash is again real, and third is the position. The position we already size.
So object at the center of curvature of the mirror. So this is again your concave mirror. This is the pole, and this is the center of curvature. And this is the principal focus at the midpoint of pole and principal focus. So initially we had object at infinity, then closer to the surface, that is beyond C, but now the object is at C. So AB is the object at C. Now we can consider One ray that is very convenient to consider is parallel to the principal axis. So a ray which is parallel to the principal axis passes through the principal focus after reflection. So this is the ray of reflected after it is incident parallel to the principal axis. Now another ray we can consider now in this case, let us consider another ray that is passing from the principal focus. So a ray passing from the principal focus and then incident at any point on the surface of the mirror. So this is a ray, and we know a ray which is passing from the principal focus, incident ray will be reflected parallel to the principal axis. So ray is reflected parallel to the principal axis. So it meets at one point, that means this point will now serve as the image of point A. And the image of point B lies somewhere on the principal axis. Let us draw a normal, a perpendicular from point A. So this point is B dash. So A dash B dash is the image of AB. Now, number one, what our observations are: number one, the position of the image is at C only. So at center of curvature.